Solar nuclear fusion. So in this project, we will learn about the source of the energy of the sun, how it is made, and what we use it for. So before we get into, the source of the energy from the sun, the nuclear reactions and everything, I just want to show a quick examples of what we use the sun's energy for. Solar panels are used. We have plants that, quite depend their lives on the sun's energy, and so do humans. What is nuclear fusion? Nuclear fusion is the type of reaction that occurs inside very hot and giant objects such as the sun or nuclear bombs. We know that everything in this world is made up of matter, and matter is made up of atoms. In the center of the atom is called the nucleus, which consists of protons and neutrons. The reaction that occurs in nuclear fusion is when a number of protons and neutrons come together to produce a new element while also releasing a lot of energy in the process. So what I'm basically saying here is nuclear fusion is when you have one proton and you have one neutron and they come together, they fuse, and at the same time, they release tons of energy. So that's what nuclear fusion is. Nuclear fusion reactions are very hard to replicate. It makes sense. And is only naturally found inside the core of stars such as our sun. This is because nuclei, protons and neutrons, repel other nuclei, and it's almost impossible for them to come together or fuse unless a tremendous amount of heat is applied, which forces the nuclei to bind together, which creates nuclear fusion. This enormous amount of heat is found in the sun. So in general, in normal circumstances, the nuclei, like the protons and neutrons of one nucleus, tend to repel protons and neutrons of another nucleus. So they usually don't ever come close to each other unless the environment is super hot, like our sun. Then they will be forced to bind and fuse together. Nuclear force. There are two types of nuclear forces that we will discuss. One is a strong nuclear force and the other is a weak force. In a strong nuclear force, this force is the one that binds the protons and neutrons together and stabilizes them. In a weak nuclear force, the identity of protons and neutrons are changed, meaning that a proton can change into a neutron and vice versa. So what I'm saying here is a strong nuclear force. So, you have a proton and a neutron. What is the thing that binds these two together? It is the strong nuclear force. Otherwise, if you don't have the strong nuclear force, everything in the nucleus will just fall apart. And in the weak nuclear force, the proton actually can turn into a neutron and the neutron can turn into the proton. So that's what the weak nuclear force does. It changes the identity of the individual protons and neutrons. Beta decay. Beta decay is the changing identity of a proton to a neutron and vice versa, as mentioned in the previous slide. So yeah, we talked about how a proton can turn into a neutron. So that term is called beta decay. Neutrons are slightly heavier than protons. So when a neutron loses mass, it will become a proton. However, since a proton weighs less than a neutron, there is no way a proton can gain mass and become a neutron by its lonesome, unless it is connected to a clump of other protons and neutrons. Beta decay is important when discussing how the sun's nuclear fusion works. So yeah, this is a explanation of beta decay and how it works, why it works. So we said that the identity of protons can change into neutrons and neutrons can change into protons. So why does that happen? We know that neutrons are generally slightly heavier than a proton. So if for some reason the neutron decides or just somehow loses just a bit of mass, it will instantly turn into a proton. So that neutron becomes a proton. But yeah, so since the proton weighs less to begin with than the neutron, and if it's alone, it's just impossible for that proton to turn to a neutron unless it is in a clump of other protons and neutrons. So let's say we have like 4 protons, like 3 neutrons, then one of these or even more of these protons can turn into a neutron since it's in a clump together instead of by itself. And yeah. So now that we understand a little bit, so it begs the question, how does all of this apply to the sun? How exactly does the sun produce energy and light? Since we know what a nucleus is, the center of the atom, and what it consists of, the sun is mainly made up of a single hydrogen nuclei with one proton only and nothing else. This one proton, you can consider it as a ball-shaped object, will bump, so this one proton will bump into another proton, but this doesn't create a nuclear reaction because you need a neutron to do that, hence the name nuclear reaction. You need a neutron and a proton binding, fusing together to cause a nuclear fusion reaction. So using our knowledge of beta decay, we know that it's possible for a proton to turn into a neutron, and that nuclear fusion requires a proton and a neutron, and not a proton and a proton. So when and how does one of these protons turn into a neutron? It is a very rare case, but it does occur. When one proton bumps into another proton, one of these protons will turn into a neutron. So now we have a proton and a neutron. Hence, at the same time, we have a nuclear fusion reaction. So we've discussed about how beta decay creates nuclear fusion. We left off with the fact that when a proton bumps into another proton, in very rare cases, does one of these protons turn into a neutron, thus creating nuclear fusion. But what next? So since we have the element H2, hydrogen 2, which is basically this one proton and the neutron, that's what you call H2. This H2 element will bump into another proton. So you have H2, one proton, one neutron, bumping into another singular proton. So now you have two protons and one neutron. We call this element helium-3. And this this process at the same time, when these two protons fuse with that one neutron, it releases tons of energy. So soon enough, another helium-3 element will form and bump into our helium-3 element, and finally producing the stronger element helium-4, which also produces tons of energy. So to sum up this project, in one sentence, I will say that the source of the energy of the sun comes from hydrogen fusing and turning into helium. And that is where we get all our energy from. So there's a quick little video that will explain it much better than I can. And it's pretty simplified to understand after everything I've said. So yeah, let's watch this.
Now, we have finally covered enough background to explain how the sun shines. This was worked out in the 30s by Hans Bethe. The sun is mostly made of hydrogen 1, which is just a proton. The sun is very hot and very dense, so these protons collide. But this doesn't cause a nuclear reaction because there's no neutrons. Most of the time, when two protons collide, they immediately fly apart, producing no energy. But it is possible, very, very rarely, that something else happens, beta decay. At the moment the two protons collide, one of them undergoes beta decay and turns into a neutron. This gives us hydrogen 2 and releases tons of energy. The hydrogen 2 nucleus continues moving around, and when it bumps into proton, it turns into helium 3. And this releases tons of energy. As this process continues, the sun produces more and more helium 3. When two helium 3 nuclei collide, they can form into even better combination, helium 4, and this releases tons of energy. Hydrogen is converted into helium in 3 steps. First, 2 protons are combined into deuterium through beta decay. Next, a proton is added to make helium 3. And finally, 2 helium 3 nuclei collide, creating helium 4 plus 2 leftover protons. The first step is by far the slowest because you have to wait for beta decay. For a typical proton in the center of the sun, the first step takes, on average, 1 billion years. Compare that to the second step, which takes about 4 seconds. Now, the final step, you have to find another helium nucleus, which is rare. This takes about 400 years. These nuclear reactions are the source of the sun's tremendous power. The sun is the ultimate energy source. The sun heats the air, which causes wind. The sun heats water, which causes rain, giving us hydroelectric power. Sunlight is the foundation of life. The energy from ancient life was deposited into the ground, giving us our fossil fuels, coal, oil, and natural gas. Practically all the world's energy ultimately comes from either the sun or nuclear power. To summarize, we present Children Explaining Nuclear Physics.
Hydrogen one asks, the sun is made up mostly of. Now, what if two of them collide? Then one of them will turn into a neutron and you get hydrogen 2. Next, they collide with another atom and you have helium 3. And then it collides with another one and you get helium 4.
Beautiful.